Okay, now what is variable? Variable, as you can see, that and in fact I was calling it, where is the example I gave about this? Yeah, that one. So I call this variable, right? I call that the pizza price is my variable. So what is this variable? The value, the face value of x, actually, that what is lying under x, what this x refers to. And this x can refer to, height, weight, number of siblings, gender, marital status, eye color. For example, doing, or doing some research on stock market, the prices of stock will be my variable. Okay, so uh, as I have written here, a characteristics that varies from one person or thing to another is called variable. Okay, how does it vary? For example, my research area is eye color. So the guy A has blue eyes, guy B has black eyes, guy C has what you call the green eyes, etc., etc. So you see that from each person to another there is actually a difference. So and that difference is called, the variation, actually. So this is why we call it the variable. Either it is age, for example, someone is 25 years old, the other is 27 years old, the next is 29 years old. Okay, so and this variation, because of this variation, actually, and we call it the variable. So variables are, whenever I say variable, it simply means that the face value of x, face value of x, that what my x, for example, is age. Let's say my x is age and the height is 29. So I would say that this 29 is the face value. Okay, and this is, and the entire age is actually my variable, which is changing from person to person, item to item. Right. Now, there are two types of variables. Okay. One is, quantitative variable, or the second one is the qualitative. From the name itself, you could have, I guess you could have understood that it says the first three variables, for example, the first three variables yield numerical information and are examples of quantitative variables. For example, height, weight, number of siblings. So it contains numbers. Height, it could be 150, 160, 190, 200. Weight, 85, 90, 20. Number of siblings, three brothers, two sisters, one sister, one brother, etc., etc. So all of these variables contain number, and that is called quantitative variables. Whereas if you look at the next three variables, okay, these, for example, gender, marital status, eye color. Gender, either male or female, there is no number. Marital status, either not married, divorced, separated, etc. Okay, so this is again no number. Eye color, blue, green, brown, etc. Okay, and that is called qualitative variables because it refers to the quality. This is how we explain the quality. Now, the qualitative variables actually has no types. Okay, I'll come to that point later. But let's begin with the quantitative variable. That what quantitative variables, first of all, the meaning, which contains the numbers, the mathematical figure. It has two types. One is called the, discrete variable. The second is the continuous variable. So what is discrete variable? When you have, I have just written, when you have whole number, when you have, as this decimal should be here, I think this is just typing mistake. Whole number, for example, I ask you, hey, how much you have got out of 10? You say, I got 5, 7. Your height 150, your score, football, in football match 2. So all these numbers, which are in the full number. Whereas the number, for example, some marks, if I ask you, hey, what is your score in in my class, you say 5.5. So this 0.5, you say, I say, hey, what is the speed of car? So you may say 120.5, sorry, 120.5 per hour. So 0.5. So whenever you see this continuity, when you have a scale, for example, Okay, so how do you define the scale? Let's say this is 0, 5, 10, 15, and then in between you have 1, 2, 3, 4, and 5. So let's say you lie here, let's say 2.5, 2.6. So have you seen the scale? You would find small, small, that marks which helps us, to know that the decimals, actually the points. Okay, so whenever you have data in points, in decimals, and like for example, your age, your anything that can be in points, always called the continuous variable, whereas the discrete variable always the full number, which does not have. And one more characteristics, I would say, that this is continuity. It continues. It continues. The data goes on. For example, stock market prices. The everyday data is continuing. It does not stop in one place or at one point. It goes on. Every day you see the different prices, right? So this is the very major differences between the discrete and continuous differences of variable. We will be doing this when we do the software. Now this categorical is basically for analysis point of view. It's not a part of descriptive statistics. It's more part of inferential statistics, that when you have data, again, the same data, okay, the same variable like x or y, whatever, but it is when it is in nominal and ordinal. In fact, when you work on the softwares, you always see the option. It asks you, hey, is this nominal or is this ordinal? Okay, so let's see what is nominal when it is divided into the categories. It's also called categorical data, categorical data. But in books, you always find this definition, okay, because this is more descriptive, but this one is more inferential. So nominal data, which refers to the what you saw called the characteristics, actually, okay, and ordinal data, which can be in order 1, 2, 3, which can be in options, okay, and for example, sometimes you collect a survey, okay, and you ask, let's say you are conducting a survey on household or income or anything, that do you get bonus from your company, or how many, or yes or no, how many times do you visit, or do you go to the malls for shopping, etc. Okay, do you go, yes or no? When you see these kinds of questions, when they are in options, when they are in orders, they are called ordinal data. So how will you remember? Order, ordinal. Okay, and when you have nominal, like characteristics like black, like white, okay, short, big, small, fat, thin, all this is called the nominal data. So when you type data, when you put data into the computer, into the system, it will ask you that what is the nature of this data. When you have this, you will just simply put in nominal and ordinal. Okay, can it affect the analysis? To great extent, no. To small extent, yes, it can. For example, if you have wrongly put the data, most of the time, in fact, when you do this, you hardly find a major difference, but it can still affect your interpretation, okay, of data. Uh, Now, this is called the variable, but what is data? So data refers to the values of variable. Are you getting my point? So what did I say? I said the face value. Where is the point? Yeah, I said the face value of x, and then now that x has the value, and that value is called the data. For example, number of people living in a country, 5 million, 6 million. Likewise, we have different types of data, again, qualitative and quantitative, like exactly like the variable, because of course, variable is kind of, it is also data, by the way, but it defines that what the which category this data actually belongs to, okay, or what are the characteristics. So for example, qualitative and quantitative, and again discrete and continuous. When we have discrete numbers like whole numbers, full number, and continuous when we have in decimals, when there is a continuity which can be measured on a scale. That's basically the what you call the continuous data. So I can ask you in exam, for example, what are the types of data, okay, or what is continuous data? Give me some examples of continuous data. Or I can create a situation where you have to recognize that whether this or it belongs to discrete or continuous, okay, these kind of things. Just a moment. Okay, okay, now recording.
Professor, one more question.
Yeah, please.
According to the diagram you showed, quantitative data consists of discrete and continuous, right? Or not?
Yeah, that's true.
But here you are showing that it is like different for groups, like qualitative, quantitative, discrete data, and continuous.
No. So as I tell you, this is not for you. Just look at this, for example. So quantitative data, for example, quantitative data. No, because I have already created this difference here. So
Yeah.
that's why I didn't spend a lot of time on that.
Oh, yeah, I
Yeah.
see.
Yeah, let me write down quantitative. This one is discrete, and this one is continuous. Okay, nice, clear, right? Okay. So next is, in descriptive statistics, I must tell you that sometimes, not sometimes, in fact, we were discussing yesterday that we have to show our data through charts and through, diagrams. And when it comes to charts, of course, I'm not going to draw charts here because I will be doing it on Friday. But there are a couple of charts that we often use. For example, you must have heard pie chart. You know that sometimes you happen to see this, in different colors. Let me just show you that how pie chart looks like. Okay, likewise you can sometimes see the bar chart, or you can see the line charts. There are different types of charts through which you can actually present your statistics, right? For a, can you tell me how many people are living in Kyrgyzstan and according to the region? So you say yes, why not? So you say, hey, this is Bishkek, this one is let's say 1 million people. Jalalabad, for example, I don't know, 50,000 people, or this is equal, maybe 10,000 people. Likewise, you can describe, and there are several other ways to describe as well. Okay, so this chart, one of the charts actually, which I would like to little bit focus on, because our probability distribution is very much based on this histogram charts, and because of the our data, when it is so big, we have to actually how we can actually organize, because this is what this descriptive statistics is all about, the description and summarization of information of data, isn't it? So let's do a small focus on histogram, okay, and then learn a couple of terms related to a histogram, and then move on to the outliers. That okay, so no worries about this chart. I will be creating in 2 seconds, on Friday. So you don't have to be worried that you don't know how to create these tables and all. You would be doing it without any problem. Okay, just not today, but on what is this histogram? Okay, so you must have seen this chart very quickly, directly taking you to this kind of charts. You must have seen, you must have seen, or whenever you are going through papers, or research papers or books, or some reports, you always find these kind of charts. Okay, let's understand the first of all how we can draw this chart, here, and then analyze that. I have already written this portion, that usage of histogram, although I have written and explained with the help of this, what is the usage of histogram, why do we need histogram, and what is the purpose, and again the usage in sampling distribution. Okay, uh, let's say this is what to say, this is the score, we can say. Okay, I haven't written anything. Then let's say this is the score of students, okay, out of 100, assume, because I can see some marks 50. So let's say this is the score okay, scorecard of my class out of 100. Okay, and I can see that there are many students who actually got 18, you know, this one, sorry, this one, this, and two students, likewise 19. I think how many students? Two students, 18, 18 to 19, I think 19. Yes, one more. So what we do, let's create a, sorry, let's create a table. Let's make a table. So we can call it X, yeah, and we can call it F, like frequency, yeah. Okay, so my X number one is from which number to which number. I think the minimum score is 18 if I'm not mistaken, and the maximum is 54, right? So 18, okay, 54, oh, sorry, so 18, and then we have 19, okay, and then we have 20, and then we have, what next is 27,
21,
21, 22, isn't it or not? 22 is not there, I think. It's there, it's there.
There is
22, and I think I need big chart. Okay, 22, and then what next?
24.
24, 24, and then what next?
I guess
29.
29,
29,
27,
3rd.
7, 29.
Oh, we have 27.
27 is also there. 27 is also there. So
24, 27, 29.
29, and then next 30, 30,
Yeah.
right? 30, and then next, what is next? 32,
This is
right?
32, 33.
Yeah, 33. Okay, anyway, so on. But now let's see how many, and then it will go on. Okay, it will go on, and we will cover all the marks. And then let's see how many students got 18. I think 1 and 2, isn't it? So 2 students got 18. How about 19? 19, 1, 2, 3.
Three.
3 students got 19. How about 20? 1,
We have three 18s.
huh? Sorry?
We have three 18s.
Yeah, we have 3 18s. That's true. We have 3 18s. So 3 and 20, how many? I think 1. I think 1 just.
220. 220.
220. You can assign the frequencies. Now, after that, let me draw somewhere. Where to draw? I need not here. Okay. Then let me just create. You make it X and Y. So let's say this is my X-axis, 0x, and this is my Y-axis. Okay, so X-axis and Y-axis. Here you put the frequency always, and here you put your variable, whatever the variable is. Okay, whatever the variable is. Right. So what is, let's say, your frequency lying from 1 to 1 minute. Your frequency lying from 1 to which? From 1 to, let's say, yeah, here. From 1 to 1, 2, 3, 4, 5. Like some students, you know, 5 is the highest frequency, for example. And here, now here we're gonna put the variable. Okay, so variable if we plot each and every digit, then it will be very long. So what we're gonna do, we can define in 5 digits. So for example, 0 to 10. Okay, or let's say 0 to 5, 0 to 10, 5, 10 to 15, 15 to 20. Okay, and then let's see, for example, 18. The first is 18. So 18 will lie somewhere here. How many frequencies? Actually 3 frequencies. Can you see here? These 3. Okay, next 19. 19 also 3. 19 will also lie somewhere here before 20. So 19 will also be here. Next 20. 20 is 2. So 20 will be here. Next is 21. Next is 21. Somewhere here it will be 1. Okay, so guys, what you are going to look, you are going to see somehow this kind of chart. Okay, I don't find the space. You are going to find this kind of chart actually, for example. You get my point? Something like this or like this. So here you're gonna put the frequencies. Here you're gonna put the variables value, okay, or what we call the X. What we call the X. Okay, now, so this is called actually the histogram. So what is the benefit of histogram? First of all, why do we use histogram? Number one, the most important benefit is when you have such a large or big data, what you can do, you can actually make it, a very small. Because if you say, hey, one student got 18, he got 18, he got 18, she got 18, then what you're gonna say, that 18 score has been earned by 4 students or 5 students, and accordingly you create the frequencies and you draw the chart. So with this chart, and instead of just writing, for example, 0, 1, 2, 3, instead of that you just delete it and you just simply say 0 to 5 to 10 to 15 to 20 here, and then here frequencies, and simply you draw the. If I want to know the mean, can anybody tell me the mean of this question? What is the mean of this question?
I think that should be around 30, mid-30s.
So if one of you can tell me, or do I need to do?
Just a second, I will do that.
Okay.
Yeah, give us a second. Yeah.
Okay, 2 answers I got. Anyways, so 28, let's say the mean is 28. Okay, so when where does the 20 lie? For example, in this chart, where does the 20 lie? 20 lies somewhere here. So let's say 20 lies somewhere here. Okay, 20. And if we make the, for example, 18 is somewhere here, and the frequency is like this. Okay, so what is the advantage of histogram? That with the help of this I can calculate actually how far, in frequencies we are far from the mean. For example, the average is 20. Let's say 20, it was 28, sorry. Let's say the average was 28. Okay, 3 students got 18. Okay, which means that on an average my 3 students are not very far from the mean. Okay, but one student, and let's say that there is 5 or 6, or there are 5 or 6 students who got actually 45, or 45 we know that lies here, and they are in the highest frequency. So we can see that our data is from here is moving on to there. You see the variation, that 3 students got 18, which is very close to 28 or 20, whatever the mean you assume. And on the other hand, there are 4 or 5 students who actually got much higher than the average, which is 28, and they got 45, and their frequency is very high, like more than 3, 4, 5, 6, 7 students. Okay, so eventually what you happen to find, this kind of chart actually. When you draw this simple, standard, what you call the frequency distribution, for example, in this case, so you will find this kind of chart. Isn't it or not? Do you understand it or not? When you draw the chart, I mean, it can take different shapes. It can, because of the frequency, it can take different shapes. Let me just quickly find, because I feel uncomfortable. So here I find this new page. Okay, let's say this is my frequency distribution here, F. This is my X here. Okay, and this is my mean, my average, my mode also here, because this is what we say, that mean, mode, and median the same actually. So here my mean, my mode, and let's say lying at the same point. Okay, and then this is my frequency distribution. So when I draw the chart, let's say this is my 0 to 5, 0 to 10, 0 to 15, 0 to 20, 25, etc. Okay, so 5, those who got 5, 2 students, those who got 10, 3 students, those who got 20, just 2 students, those who got 25, let's say 6 students. So if I draw the chart, this chart will be drawn something like this. And if I remove this frequency and other distributions, so how will it look like? It will look like this, isn't it?
Right.
Yeah, and that is called the histogram, right? And very, very useful concept, very, very useful diagram. I'm sure you will be getting bored of seeing this diagram. It will come so frequently that one day you will say, oh, I want to get rid of this diagram. Okay, because as I mentioned, so usage of histogram. So we understood what is histogram. We understood the frequency distribution. We understood the importance of mean, mode, median within histogram. Now, what is the usage of that? The first usage is what distribution center, which shape does the data have? We can understand that what is the shape of my data? How does it look like? Now you may ask me, Kashif, so okay, for example, just a moment, for what is happening? Yeah, so for example, you may say, okay, where is the chart? Okay, for example, okay, we learned this is the chart. Okay, this is the diagram we got. This is our hidden histogram. So what is the benefit actually of getting this? Actually, with the help of this diagram, we can only find our outliers, to be honest with you. Okay, and we can understand the nature. What nature am I talking about? I'm talking about the dispersion, that how my data is dispersed. For example, look at here. If I draw, look at here, this frequency distribution is high compared to this one. This frequency is the highest, this frequency distribution is the highest. Here, the highest frequency. So just by drawing this chart, it gives me a lot of, information, just this chart. I can understand the nature of my data. Now, the next is, does data look symmetric or skewed? That's an important point. And I will just, sorry?
As for about the question, what distribution does data have? So we can answer just a chart or what?
No, it is talking about something that I will be covering in next classes, because we have different distributions. But so far, what you have to understand, that what kind of shapes and what information does this chart give us. For example, if the tail is to what you call this kind of what to say. For example, let me show you
Bell shape.
Bell shape, exactly. So when, let's say, this bell is too big, we can understand that the frequency is quite high as compared to others actually.
Oh, I see.
You get my point? And if data is good, going too skewed towards right, it gives another meaning actually. Okay, so distribution I have written, but I will be covering in my next class. But just for today, you just understand this. Next is, does the data look symmetric or skewed? I will come to that point. Just okay, this one, and my data is something like that. Okay, and this is my mean actually. Okay, so when I say my mean in general, and even if you don't draw the bell shape, you just say mean, what does it mean? That half of the data is lying on the left side and half of the data is lying on the right side. Yes or not? Do you understand this point, all of you? I'm just concerned because you are not asking many questions. I'm just afraid.
Yes, yes.
Yes.
All of you?
Yes.
Okay, very good.
Yes.
Okay.
Yes.
So yeah, so it means that my data is lying on both sides, right? And if I draw this bell shape as I have drawn here, if the more it is, nicely bell, the more my data is systematic, okay, and not skewed. So if, let's imagine, this is the first scenario. This is the first scenario. So my data would be something like that. Now you can say, sir, how actually? Because I would say, look, this is half data is here, 50%, and 50% data is here, and that's why it is called the mean. But imagine that there is another scenario number 2, that this is my mean, and most of my data, 70% data lies here, and 30% data actually lies here, and the shape would be somehow different. So will it be symmetrical? No, it won't be symmetrical. So with the help of histogram, I can also learn whether my data is symmetrical or not. Symmetrical means, for the both sides, let's say equal. For example, my hand, you cannot see the other one. When I do this, you cannot see the other one. So symmetrical, which have the equal, portions divided into exactly equal parts. Okay, and the third scenario could be vice versa, that when my mean is there, 70% data lies here and 30% data actually lies here. So it means again that my data is not symmetrical. If your data is not symmetrical, then what your data is, I'm writing here that if my data, is not symmetrical, then what my data is? Simple question. Sorry.
Asymmetrical. Asymmetrical.
Asymmetrical.
Go ahead.
And in statistical language, we call
Skewed.
skewed. Yeah, very good. We call skewed. So my data is skewed towards right side or towards left side. If it is skewed towards left side, we call left skewed data. If it is right, then we call right skewed data. Okay. So now, so from this point, again, let me go back. Yeah. So symmetrical or skewed. Now the next, does the data contain outliers? Does it have outliers? So first of all, let's understand what is outlier. Okay. Through the concept which I have written, box plot, with the help of box plots. Actually, they are not two different concepts. They are very much interrelated or related, I would say. Without box plot, you cannot understand outliers. Box plot very much helps actually. Okay, and also when we do some practical questions, we would be drawing box plots, in order to understand. And as I have said before the break, that we don't need just one statistics to rely on our analysis. We need several statistics and several tests, to prove ourselves that we are, accurate and our information is highly, reliable. Are you getting my point or not? So just if you have any point, we can discuss. Otherwise, I think we have still 40 minutes. 3 hours class is too much, isn't it? Is it okay for you?
We are
Yes.
trying to keep up with you.
Okay. Okay, great. But you don't have any other class afterwards, isn't it? So just last 30-40 minutes.
Yeah, right.
Yeah, okay. And tomorrow we have just 1.5 hour class, and tomorrow I will be just doing all these things there. So yeah, I'm just explaining what is box plot, and let me just write down. And it's also called whisker plots actually. Yes, whisker or whiskers plot, something, whisker plot. But in practical language, it's called box plot. Whisker or whiskers, you may have to, you may check in whiskers plot, let's say. I think whiskers must be name, I guess. So that's why it is called whisker, I guess. So because in statistics, it's like our next topic is correlation, but I don't think we would be able to cover today. Correlation is like Spearman correlation or Carl Pearson's correlation. So Fisher, you might have heard Fisher. Fisher is the father of modern statistics, particularly this inferential statistics. So you can find some like in their names, the name of the topics, or the concepts actually. For example, likewise we called Carl Pearson's correlation, because it was given by Carl Pearson. And if you are reading statistics books, you know, these four, five guys, you know, you will find everywhere in every chapter. Whisker is correct. Yeah, correct. Okay. So yeah, you can, well, it does not concern us, but just to, like, for example, Fisher is a very important name, you know, in statistics world. Spearman also, Spearman given a very, I would say, he did a drastic, I would say, contribution, you know, and in the field of statistics by working on different aspects, you know, like Spearman formula of correlation. It's a super formula actually. In next class, I will show you that Spearman formula of Spearman formula of correlation and Carl Pearson's formula of correlation, and you would understand that what is the importance of, you know, Spearman. But anyways, both of them are very important figures in statistics. Okay, and but these things are dealt by those who are doing, you know, like graduation statistics or masters in statistics. Okay, they are more actually concerned with all these things. That's not our concern. Yeah, I remember Fisher exact test from statistics. Yeah, that's true actually. The objective is clear, that with the help of box plot or whiskers plot, what we are trying to learn actually the outliers. And outliers, you have already understood that unwanted figure or disturbing figure, a disturbing number actually, which disturbs the whole set of, you know, data. Before we move on to this, there's a concept called 5 points, you know, 5 points concept. Whenever you actually go through the book, either the 5 key data points or 5 points actually. And what are these 5 points? They are called, let me tell you, minimum number. Let me write down minimum number, maximum number. Okay, next is quartile 1, quartile, QUARTILE, quartile 1, quartile 2, quartile. Okay, and but actually we write like this, yeah, quartile 1, quartile 2, yeah, and quartile 3, Q3. So to actually know our outliers, know about our outliers, we have to know all these 5 terms. Okay, if we know all these 5 terms along with IQR, we call interquartile range. Okay, we can actually find out the outliers. But are we going to do the same thing in while working on tools like softwares? No, softwares are smart enough to, you know, recognize. In fact, you just click a box there that I want outlier, click it, and it will give you everything. You know, you don't have to calculate all these things. But the calculation is very important, because without going through such calculations, you will be confused from where this data is coming, from where this outlier is coming. And most of the time, you know, students and researchers, in fact, we get confused with the values, like from where this value has come. For example, today we spend a lot of time on standard deviation. So can't we find with the help of software? No, we can find, of course. But what we learned today, how it is coming, how it affects, so you feel much comfortable. And if you feel comfortable with the data, your analysis is going to be perfect, actually. Okay, so likewise, box plot also the same thing. Outliers will be given by the software, will be recognized in, you know, and thrown. But we should know as well from where it is coming, so where we will not be left with any confusion while doing the analysis. First of all, let's understand what is quarter. Quarter is nothing actually. That's exactly like median. The difference is only that in median we were dividing by 2, because median was actually the midpoint. That's why and quarter is quarter. Quarter means the 4, isn't it? So we will be dividing by n by 4, n plus 1 by 4 actually. But we are not, sorry, we are, what happened? We are not going to calculate quarters with the help of, we will be just focusing on actually the outliers, but we need to know what quarter is. So quarter is basically, let's say if you have this data, this much data, and I am interested in knowing, hey, what is the median? You can say, hey, Kashi is somewhere in the middle. Okay, so that is called median. I say, hey, what is the quarter, you know, the first quarter, and you will say this is the first quarter, quarter 1. So this is actually the quarter 2, and this is actually, isn't it? So median is actually my quarter 2, isn't it? Because quarter 2 50 and median is also 50, right? So what we do, let's have a small question and things would be more clear from there. So let's say I have data 6, 15, yeah, you can do it with me, okay, that's very important. 8, okay, 12, 13, 45, 25, 25, something happened, isn't it? No, okay, 25 and 50, 50, and the last one is 75. Let's say this is my data. Okay, it could be whatever you assume. This is my X, whatever you assume, score, age, numbers, whatever. Okay, this is my X. Now, first of all, what we have to do, guys, as we know that we are going to learn, you know, do the median, the midpoint, or the quartile. So we have to arrange this like we do in median. So let's arrange in, you know, in ascending order or descending order. Let's arrange in ascending order. Okay, so in ascending order, the first one would be 6. The next one would be, you know, 8, isn't it? 8, this one, and then 12, isn't it? 12, and then 13, and then 15, and then 15, and then 25, isn't it? If I'm not mistaken. And then 50, no, 45, and then 40, 45, and then 50, and then 75. Okay, so now this is my arranged, you know, order. So how many things do we need to know the box plot or to know the outliers? So we know that we should know the minimum number, we should know the maximum number, we should know the quartile 2, quartile 1, quartile 2, quartile 3. So what is this minimum and maximum? This is coming from the chapter called range, that you know, from which range to which range, from the lowest to the highest. So in this data, what is my highest range? Is actually the 75, right? So I am writing here, this one is my 75, and the lowest is 6 actually. So let me just simply, no, this color is not suitable. Let me just do this. Okay, so 6 and 75. So my highest and my lowest, or what we call the minimum number, let me write down, otherwise you may forget. Write minimum and maximum, minimum number and the maximum number. Now let's calculate the quarter, because now we need quartile. So quarter 1. So first of all, let's know what is median, because my median is actually my quartile 2, isn't it? So how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So 9 is n plus 1, 10, 5. So 1, 2, 3, 1, 2, 3, 4, 5. Okay, 15. 1, 2, 3, 4, 5. So this is my, let me just underline it. So this is my what? Median, as well as median, MD, as well as quartile 2. Isn't it? Because quartile 2 is median. So now what do we need? We found quartile 2. What do we need? We need quartile 1. So how to calculate quartile 1? So we have now this, in this figure, these figures, and now and these figures. So how many? 1, 2, 3, 4, isn't it? 1, 2, 3, 4. So in order to find the quartile 1, what are we supposed to do? Again, actually 1, 2, somewhere here in the middle. So how to find the middle number? 12 plus 8 divided by 2 is equal to actually 20 divided by 2 is called 10. So 10 is my quartile 1. Get my point or not? Likewise, 1, 2.
Can you explain one more time, please?
Okay. Did you understand the median quartile 2?
Yeah.
Okay, then divide the data into two parts. One part is this, one part is this. So in this part, how many digits are there? 13, 12, 8, 6. 1, 2, 3, 4. So what should be the median? The median between 8 and 12. So how do
Right.
we do? 8 plus 12 divided by 2 is actually 10. So 10 is my quartile 1. Clear? Clear?
Yeah, thank you.
Okay, welcome.
Yes.
Likewise, the same thing. 1, 2, 3, 4, 25 plus 45 is going to be total going to be 95 divided by 2. It's going to be 44.4, no, 90, no, 47 something, the 47.5. 47.5 is my quartile 3. So now we have now minimum number, we have maximum, we have quartile 1, we have quartile 2, we have quartile 3. Okay, all what we have to do, I have a message, let me check what this message is. Q3 is 47.2. Yes, thank you so much. So this one I have got. Now we need to check the slowly we are moving on to the outliers. Before we, what is outlier? Outlier is something that you don't want because this digit is disturbing you. But can you tell me in this data, or can anybody think or you know that something is unwanted? You may say
75.
yeah, I know that you would be your answer would be 75 because, but this is your according to your calculation, according to your observation. Okay, maybe this is not outlier, because when a data is based on algorithm table, which I'm not very much familiar with, but maybe 75 is actually maybe the not the outlier. But when you I know because you feel that all digits are closer to each other, 45 seems okay, but then we have 75. But we are forgetting that from 25 to 45 is also a big difference, that is 20. So do you believe that just by 5 you are going to say that you are an outlier? Are you getting my point or not? Because
No, we're not sure about that.
yeah, exactly the point I'm trying to make, that we are not sure about it. Because when we see that, yes, if the answer would be 175, I would say, or you would say, yes, this is absolutely an outlier. So let's check. Maybe I'm wrong, maybe you are right that 75 is outlier, but according to my understanding, based on what I can see the differences, it should not be an outlier. Okay, then and I say anyways, so what next we do, we find IQR. What is this? Interquartile range. Interquartile range. So this is the formula to know actually the number. Okay, now look at for example, this is the formula Q1. You have to remember it. Unfortunately, you have to memorize 1.5 IQR. Maybe if you have a mathematician teacher, you can ask that why is it multiplied by 1.5 and something. It's a proven actually based on some theory. Some answers mathematicians can give very well actually, that we would be learning in future, particularly in normal distribution. So 1.5 and 1 minus quartile 1.5, and here quartile 2, sorry, not quartile 2, it should be quartile 3. It should be quartile 3. So we can say here let me write 2 quartile 3 plus 1.5 IQR actually, interquartile range. You get my point? So our range is actually Q quartile 1 minus 1.5 IQR to Q3 plus 1.5 QR. That our number range should be from this to this. If the data is lying, if the digit is lying between this, then it is not an outlier. If it is lying, beyond or below, then it is an outlier. Okay. What is IQR? IQR formula you can write here: Q3 minus Q1. Yes, Q3 minus Q1. So what is Q3 quartile? We have already calculated, which is what was the quartile 3? 47.5.
47.
Yeah, 47.5 minus Q1. Q1 is what was the Q1? I think 10, isn't it? 10. So my IQR is going to be 37.5, isn't it? This is my IQR, interquartile range. Then let's put this IQR here. So my Q1 is 10 minus 1.5 multiplied by 37.5, 2 or comma, whatever you like, 10, no, not 10. It is quartile 3. It should be 47.5 plus 1.5 multiplied by 37.50, and you guys can tell me the number, I think, or let me just see myself. It is 1.30, 1.5 multiplied by 1.5, and it is minus 46 point minus, actually it should be
Minus 46.25.
Okay, very good. Thank you so much. And what about the next one? Can you tell me the next digit?
Just a second.
Mm-hmm.
$101.75.
101.
Yes.
103.
103. Really?
103.
Okay.
Yes.
So 103. So my range is actually my range. If I draw this, my range is from let me write down here, from minus, what was the number? From let me write down, from how much it is, minus 46.25 to 103.75. So what does it mean? It simply means that if my data, or sorry, digit is lying between 1.40 point, not point, minus 46.25 to 103.75, it means that I don't have any outlier in this series, in this data set. And you can see that my data is from 6 to 75, and 75 is within 103, because this is from minus 46. So I have plus 6, plus 6, and that's why from in this question I don't have an outlier. Okay, one thing. But we haven't solved the question like what is box plot and how then the outlier will be shown. Okay. So what we can do, let's say we plot some digits here, for example 0, okay, 0 to 25, 50, 100, 150. Why? Because our range is from, it is in minus also, but we are not going to cover minus, so we are taking from, because our digit is starting from 6, so minimum to maximum. Okay, so 0 to 150, we take a scale. Okay, any scale you can take from 1 to 1000, 0 to 1000, but take something that your digit can be included. For example 6. So if you start from 10, 6 will not be included, so be careful. So we are starting from 0. Okay, this scale. Now let's draw the chart. So for example, you must have seen so first of all, the minimum number. So minimum number is 6. So where does the 6 lies? 6 lies somewhere here. Just make a small what you call point here. Okay, this is minimum, sorry. Where does the maximum lie? The maximum number is 75. So 75 lies somewhere here, isn't it? Somewhere here. 75, sorry, somewhere here. Here, right? And how about here? Okay, how about my first quartile? Okay, but my first quartile is 10. So my first quartile would be falling somewhere here, isn't it? First quartile would be falling somewhere here. Okay, let me use this one maybe. Yeah, first quartile would be falling somewhere here. And the second quartile is, what was the second quartile?
45.
What was the second quartile? I forgot.
45.
45.
Yeah.
No,
No, actually,
no,
47.5.
no,
It was 15.
Oh, yes,
15. Yeah, 15. So my second quartile would be falling. My just a moment, sorry. So my second quartile would be falling somewhere here. Okay. Now, and the third quartile, what about the third quartile? Is 45 will be falling somewhere here. Do you understand this or not? Now, what you're gonna do? You're gonna make the 3 quartiles box. So you start from the quartile 1, end with the quartile 2. Okay, quartile 3, sorry. Just draw this box, and this is your quartile 2, quartile 1, quartile 3. And this is your minimum range, and this is your maximum range, and here it is your box plot. Now if you say the answer, it is actually there is no outlier, therefore there is no problem. So this is actually called the box plot. Okay, when you draw with the help of computer, then it will show this box plot. It will always only show this box plot, and you have to understand from this chart. I hope it is clear. If you have any doubt, you can tell me, and I can give you one more question, but I don't have enough time. Also, my energy is almost gone. So what I'm trying to do, one question where there is an outlier. Okay, we can do, or maybe shall I give you and you can do now quickly, very quickly, all of you?
As a homework?
Not as a homework, as a practice, so that I can see.
let's try.
Yeah.
Yes.
Okay.
I think it would be better. Yeah, it would be, so that we will be done with descriptive statistics today. So this is the end of descriptive statistics. Okay. Next class we would be doing all these things, and one more concept which I was supposed to cover today, but I couldn't. That is correlation. So my next class I would be starting with correlation. Okay, and then I will also do, if time permits, regression. Okay, linear regression, at least one regression, particularly least square method. Regression is helping us to predict, for predictions and all business. It has a lot of, when I teach finance actually to my students, I also teach regression there, because in finance also regression has a very big application and very, use. The usage is very high actually. So shall I give you a small question and you can do, and you can tell me the outlier? Is it okay?
Yes.
Okay, very
Yes,
good.
okay.
Okay, very good. So on the screen, I'm giving you a small, it's not a small question, but just, let's say, I don't know whether, because I'm just assuming this question, so I hope that there will be an outlier. So 15 or 17, okay, and 34, 56, 120, okay, 19, and then let's say 45. Okay, this is your question, and you have to tell me if there is an outlier or not.
120 is
One-
outlier.
Okay, did you find?
Yes, yes. 114.5 is the maximum range.
And then 120. And did you draw the figure chart also?
That's self-explanatory, but yeah.
Okay, very good. So is it, who is this? Who is this? Who is speaking now?
Two people said it. Me and
Okay.
one other person.
Okay. Okay, very good.
Give
So,
us a second, we will check if the guy's right.
sorry.
Can you give us a second? We will check if the guy's right or not. So we will make sure that.
Minimum is 41 minus 41.5, maximum 114.5.
Why minimum is minus?
17 minus
No,
1.5 times 33.
Mhm.
39, sorry.
Yes, yes, correct.